many of us remember like this as our childhood. It's something that we always can connect with. Working with Jeff Parks as well as our team will be able to create a dynamic sound system that will take into account the position and orientation of a saber blade. Our team consists of 4 different WE engineers. First off, we have Kristen Milnes, who is in charge of full integration of the design. We have Ms. Sabrina Thompson, who was in charge of communication as well as coding for the actual playing of the sounds as well as the microcontroller. And then finally we have Haley Curry, who was in charge of the final design as well as development of the different parts and the actual PCB layout. We went into a couple different phases in this. The main was actually building the board, where we enhanced the actual original design that we were provided by Jeff Parks and made our own development board and then a final design. If you see, we were actually able to shrink the original developmental board into the saber handle that you'll see up top. And then later on, we took the pseudocode that we created during this Senior Design 1 and actually implemented it. So we're using a sound matrix that takes in, we have preloaded sounds that will actually have different frequencies. And as according to the position and orientation of the blade itself, it'll actually choose the frequency and be able to play it smoothly. We found that originally the Arduino actually had memory limitations, and so we actually were able to optimize the actual transition by optimizing the sound as well as reducing clipping as well as easy transition between the blades or the actual movements. We really didn't have any feedback from Senior Design 1, so we actually created our own. So we wanted to make sure that we had more quantizable data, so ensuring that we had numbers to show for our progress. We wanted to make sure that we had 90% movement to sound accuracy as well as recognition of the different sounds that we created. So we actually made custom sounds. So we wanted to make sure the audience that we were with actually recognized these are lightsaber sounds. One of the last things is we actually took on the job of creating a case for the board itself. We created a tube so that it would actually amplify the sound because the speakers were not loud enough in order to actually show the sound itself. So we actually took it on and actually amplified the sound using that case. Our deliverables were actually a BOM as well as a final design as well as customized sounds. And we were actually able to deliver that under a $40 budget. Does anyone have any questions? Yes?
I would think the amplifier and the speakers would be, and possibly the speaker box would be just strong. And piezo speakers are really efficient, but not necessarily like you want buzzer sounds. What did you end up doing there?
The speakers we wound up using are actually laptop speakers. They're sort of oblong ovals. And then we used some current amplification and then that on top of working with the acoustics of the tube that our assembly actually sits in. We were able to amplify and make sure that all of those lower frequencies that are important to the bass and the strength of a lightsaber sound were actually audible. So it was a very large challenge in this project. It was actually, I think, a good quarter of what we spent our time doing this semester.
So you physically tied the speaker to the pipe very strongly, or?
So the speaker is anchored to the PCB, and the PCB sits in the tube sort of like this, and it sits sort of horizontal. With these speakers, there are 2 of them, and they sit on the PCB. And we have a small cutout above each speaker, and we have the rest of the PCB that extends to the LEDs. You can see another picture up there. That part is sealed off, and the other end is left open so that we can push sound in from the small little slots and out to the other side.
Yes.
So how do you determine, or is it really the position of the saber, or more like how fast the person is swinging?
It's a little bit of a different thing, or I guess Sabrina and I worked sort of jointly on the code and figuring out exactly what thresholds, but we actually have an accelerometer and a gyroscope, which together work as an inertial measurement unit. And we take, accelerometers are more accurate moving fast, and gyroscopes are more accurate for slow movements. So using that and a bunch of math, you can essentially determine the position of the lightsaber, and based on how fast that position changes, you hit faster, slow, higher or lower frequencies.
Yes?
When
When you differentiate your accelerometer, do you count a bunch of noise?
The library that we actually use for all of our accelerometer and gyroscope measurements was actually already provided. It was openly available. The two parts that we used were actually this module was first developed for FIRST Robotics, so there was already a position library available, so I can answer any questions about how it got started. I'm sure it's in there though, given it's developed for FIRST.
Is your client gonna actually use it?
Yeah, he's been sort of involved in listening to, so our client is actually the guy that produces and sells all of the mechanical